Hello everyone, my name is Emertxe and today I'm going to present my internship project, which is simulation of washing machine using PIC16F877A microcontroller. The objective of this project is to create an interactive washing machine interface using digital keypads, display ongoing functions and time, pause on the door open for safety reasons. These are the contents that we are going to cover in this presentation. Introduction about embedded systems, then intro about embedded C and its comparison with C programming, about PIC16F877A microcontrollers, peripherals that have been used in the project and the software tools that we have used, key functions for the project demo, and then the conclusion. So, introduction about the embedded systems. So basically, embedded system is the combination of both hardware and software. Embedded systems perform specific tasks within larger systems. These are usually found in devices like smartphones, cameras, and appliances, home appliances, etc. Consist of microcontrollers and software optimized for task and multitasking. Embedded C. So Embedded C is a hardware-focused variant of C, allows low-level control for real-time applications, and C program. When comparing it with the C programming is a native development in nature which is hardware independent, and it is usually used for desktop applications, OS, and PC memories, whereas Embedded C is more of a cross development in nature dependent on hardware architecture used for limited resources like RAM, ROM, and input-output peripherals on embedded controllers. Then coming to data types in C. Data types define what kind of data a variable can hold. Example, integers, characters, decimals. Choosing the correct data type ensures efficient uses and the program accuracy. So there are three types of data types: primary, derived, and user defined. In primary we have int, float, double, and char. In int we store the integer values, for float and double we store the decimal values, and in char stores single characters like say A, B, C, K, etc. Then coming to the derived data types, arrays are the collection of elements of the same data types, and pointers store the memory addresses of variable, and functions are used to group the reusable code. This basically saves the memory. And user defined data types, where struct is the group of different data types under one name, and union, enum, and typedef, these are for the custom types for better clarity and reusability of code. Then coming to operators in C. Operators are used in C programming to perform operations on variables and values. They allow you to manipulate data and control the flow of program. There are different types of operators like arithmetic, relational, logical, bitwise, assignment, and conditional. And these are used for calculations, comparisons, and control of the code. Then coming to conditional statements in C. Conditional statements are used to control the flow of a program based on logical condition. They help the program make decisions and execute different blocks of code based on true and false outcomes. So we have the types of conditional statements like if else, if, nested if, and switch. And each type have different functions. If executes a block if the condition is true. If else is like if the condition is true, that block is executed, and if block is false, then the else block is executed. Likewise, if checks multiple conditions in sequence, and nested if is of if statement inside another if, useful for multi-level conditions. Switch is something which selects one of many blocks based on a variable value. Then coming to PIC16F877A brief, it comes with a bus width of 8 bits. It has total of 40 pins, and there are 33 pins for input and output. Program memory of 14.3 kilobytes. CPU speed is 5 million instructions per second. RAM sizes of 368 bytes. EEPROM sizes of 256 bytes. And these are the different interfaces, the peripherals that we have used in this project. LED, which is also called as light emitting diode, are the semiconductor devices that emit light when an electric current passes through them. LEDs consist of a semiconductor chip mounted on a reflective material and then encapsulated in a transparent lens to protect the chip and focus the light. The semiconductor chip is typically made of gallium arsenide, gallium phosphide, or gallium nitride, which determines the color of the emitted light. Then coming to CLCD. CLC stands for character LCD or liquid crystal LCD. In this we have used 16:4 display. It also has 16:2 display. Character LCDs consist of a grid of pixels arranged in rows and columns. Each pixel can turn on or off, allowing it to display specific characters or symbols. They come in different sizes like 16:4, 16:2. So 16 indicates the number of columns that are being displayed and 4 is the number of rows. To use a CLCD, you typically need to connect it to the microcontroller or other devices using a communication protocol such as I2C or SPI when we are using the actual hardware setup. Then the fan. A fan is a key component of many electronic devices and systems designed to provide active cooling by moving air. Here we have used simulated cooler which shows us that the system is on and it is being cooled. Then coming to we have also used switches in this. And the buzzers. Buzzers are for the alert, which basically defines the door status. Buzzers are small and which are made up of electrochemical components that are designed to convert electrical signals into sound waves. Typically, buzzers consist of a coil and a diaphragm which vibrates to produce sound when an alternating current is applied. Timers are for delay. So timers in microcontrollers are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing them. These are the softwares that we have used in this project. MPLab IDE, it is an integrated development environment created by Microchip Technology for developing applications for microchip microcontrollers and digital signal controllers. It is a powerful tool that provides a comprehensive development environment for embedded system developers. Some key features are core editor, debugger, simulator, device support, etc. And XC8 is the compiler for the microchip PIC microcontroller family. It is a part of MPLAB XC compiler family, which includes compilers for various microcontroller families such as PIC, AVR, and ARM. It has features like optimization, peripheral libraries integrated with MPLAB XIDE. And PICSIMLab, it is a simulation tool that we have used in place of actual hardware. Is if for PIC microcontrollers, it allows developers to stimulate and debug PIC microcontroller programs without the need for actual hardware. It provides virtual environment where user can write, test, and debug their PIC assembly or C language code. And these are some of the key functions that are used in our project. So while this switch 5, switch 4, these are the textile switches that we have used. A textile switch, also known as a push button. These switches are commonly used in electronics and electrical devices where a user interface is required, such as keyboards, keypads, and control panels. So here we have programmed different switches for different functions. Switch 5 is basically to power on the washing machine and start the program. Switch 4 is to navigating through the different programs, and if we want to select a function, then we need to long press on switch 4. And switch 6 is for pause and stopping of the washing machine. Then coming to switch 1, which shows the door status, and the buzzer is on if the door is open while the program is running. So CLCD is basically the display which shows all the functions that are being run. Buzzer, as I said, it's for alerts. Then motor fan for washing operation. And screen basically, which is CLCD, which shows us the selection, execution, and completion of the program being executed. So this is the project demonstration of my internship project, which is simulation of washing machine. This is from file. We load the hex file. From board we have chosen PIC Genius, and the microcontroller is PIC16F877A. From here we have two LCDs that we can choose. I have chosen 16x4. To power on the washing machine, we have to press key 5, as it says press key 5 to power on the washing machine. This is switch 1, this is switch 2, switch 3, switch 4, switch 5, and switch 6. Now to turn on, we have to press switch 5. This is powering on the washing machine. Now these are the different programs that we have programmed, that is daily, heavy, delegates. So to navigate through different programs, we have to press switch 4. Here from delegates, heavy, whites. So to navigation, we have to press switch 4, and so for selection of that particular program, we have to long press on switch 4. So these are the different programs: Eco Cottons, Woolens, Bed Sheets, Rinse plus Dry, Dry Only, Wash Only, Aqua Store, Daily. So for selecting Wash Only, let me press on switch 4. After selection of this program, then we have water level. So this is the water level. Again, to navigate, we have to press switch 4, that is auto, low, medium, high, max, and again auto. So to select high, we have to long press on switch 4. Okay, now I have been selected, and now to start the program we have to again press switch 5. So it has been started. So it is like for pause we have to press switch 6. So this will pause the program. And again to start the program I have to press switch 5. And while running this, if I press switch 1, then buzzer is on, which basically indicates that the door is open. Please close it for safety reasons. Now that I have removed, I have not pressed switch 1, it is going normal. Done. Conclusion. So this project involved simulating a washing machine using the PIC16F877A microcontroller in the PIXM lab environment. Through this, I was able to handle user inputs effectively and provide real-time feedback using the CLCD display. The simulation closely mimics the behavior of an actual embedded system-based appliances, giving hands-on experience in coding, debugging, and testing. Additionally, this project helped strengthen my understanding of microcontroller interfacing, port configurations, and embedded C programming. Overall, it was a great opportunity to apply theoretical knowledge to a real-world scenario, enhancing both my technical skills and problem-solving ability in embedded system development.